Alright, so here we are with Unit 11, Lesson 13, and we're going to be doing the last part of this unit. Yay! Now that we've gone through hydrocarbons and functional groups, we're going to look at some chemical reactions which are called organic reactions because they involve, well, organic compounds. And if you look at the first one, it's a type of reaction that we've already talked about, and that would be a combustion reaction. Combustion reactions, in essence, burning, involve generally a hydrocarbon, such as propane. It reacts with oxygen and it produces two products, carbon dioxide and water. So that's a typical combustion reaction. If you remember, I believe it was back in Unit 5, we talked about the different types of reactions. We talked about synthesis, decomposition, single replacement, double replacement, and we mentioned combustion reactions. So basically, to identify an organic in order to identify a combustion reaction, just look for oxygen gas as one of the reactants, and carbon dioxide and water as the two products. Reaction number 2 and reaction number 3 are very similar, and they always tend to confuse people. So to look at or to differentiate between a substitution and an addition reaction, the two easiest ways to do that is to look at what they start with. Substitution reactions always begin with a saturated hydrocarbon, which means an alkane. So substitution reactions start with an alkane. It's reacted with a halogen. It could be either fluorine, chlorine, bromine, or iodine. And what it produces is one of the first things that we talked about on table R is a halide or a halocarbon, and it produces an acid. So take a look at the example here. You have an alkane, and we can tell it's an alkane because they're all single bonds between the carbons. And this happens to be, for example, propane. Propane is a relatively simple alkane. It's reacted with a chlorine molecule, and basically it's called a substitution reaction because what happens is that one of the hydrogens from the alkane, and we're going to pick this one, is removed and it's replaced by or substituted a chlorine for it. So the H that was pulled off and the remaining Cl will join and form one of the products, an acid. And now you have a halocarbon. It's a alkane with one of the hydrogens substituted excuse me, with a chlorine. And again, to name it, this is a propane still because it's a 3-carbon chain. And we have a chlorine on the first carbon. So this would be 1-chloropropane. 1-chloropropane. So now compare that to the one below it, which is an addition reaction. In an addition reaction, it is very similar, except now you're going to start with, instead of an alkane, you're going to start with an alkene or an alkyne, still using a halogen. Notice that you end up with only one product, whereas here you ended up with two products. You ended up with a halocarbon and an acid. Here you end up with one product. So two ways to differentiate between a substitution and an addition reaction. In a substitution reaction, you start out with an alkane. Addition, you start out with an alkene or an alkyne, meaning it has one triple or one double bond. And in a substitution reaction, you end up with two products, whereas here you end up with only one product. And here's the difference between it. Because you're starting out with an alkene, which has a double bond, what actually happens is that double bond is broken. So if you break this double bond, what's going to happen is you end up with this. If you take this, if you break this double bond here, you end up with each carbon now needing to form another bond. So if you break that double bond into a single bond, and now you say, well, wait a minute, each carbon does not have 4 bonds now. So that's what happens is because you break that double bond, that opens up another bond for each carbon. So what happens is one carbon joins up, one chlorine joins here, the second one joins here, and you end up with just one product. And this would be 1,2-dichloroethane. And that's the difference between substitution and addition reaction.